All right, 4.7. This is our last section of chapter 4. So in 4.6, we were writing equations in slope-intercept form. Now we're going to be writing equations in point-slope form. I think when people see slope-intercept form, they like it because you've seen it before. It's the one you're used to. But point-slope form is actually one of my favorites if I'm asked to write the equation because it makes my life really easy. If I'm writing the equation in slope-intercept form, I have to find the slope and I have to know the y-intercept, which is a very specific point. However, in point-slope form, I still need to know the slope, but then I can use any point in the entire world on that line. It doesn't have to specifically be the y-intercept. So what is point-slope form? The equation is y minus, and I'm going to change colors here a couple times to help you, y minus y1 equals m parentheses x minus x1. And you'll see why I changed colors here in just a second. Okay, so the reason I put some color coding on here was because anything in pink, you are going to be replacing with something. Anything in black just stays as part of the equation. So you only need to have 3 pieces of information. This, of course, is going to be your slope. And then the coordinate point, x1, y1, is the point that they have given you, or a point that's on the line. So you're just plugging that in here and here. Okay, so let's take a look. It says to write an equation in point-slope form that is with the point given, 1, 2, and a slope of -4. Okay, so I'm going to write my equation. Y minus y1 equals m parentheses x minus x1. All I need to do is substitute those 3 things in. So y stays where it is, minus, well, I can label these as x1 and y1, and then guess what? My y1 is what I substitute in, which is 2, equals my slope, which they told me was -4, and then x minus, the x1 value of the coordinate point was 1. That's it. You are done. You don't have to do anything else with this. Okay? If it asked you to put it in slope-intercept form, guess what? You would have had more work to do. You would have had to use the distributive property. I'll go ahead and do that. I'm going to change colors so you can see that this is what you don't have to do. This is what you get to avoid doing. So if I had y minus 2 equals -4 times x minus 1, I would have to distribute this. So I'd have y minus 2 equals -4x plus 4 when I use the distributive property. If you're not 100% following along with this green part, it's okay. You don't have to stress about it. I'm just showing you so that you can see. And then I would need to add the 2 over, which would give me y is equal to -4x plus 6. Those 2 circled things actually represent the exact same thing. One just took a lot less work to get there. Okay? All right, so for the next one, I have the 0.70 and I have the m equals 1. To put it into slope-intercept form, all I have to do is substitute in. So I'm going to label this as x1 and y1. So it's y minus my y1 value, which is 0, equals m, which is 1, and then parentheses x minus my x1 value, which is 7. Now, the minus 0 doesn't have to be there, so I can just put it as y equals 1 times x minus 7. That's it. I'm done. Putting it in point-slope form is quick and fast. All right, try number 3 and see how you can do on your own on that one. Pause it. Come back and see how you did. All right. Oops, and this was a -8. So if you couldn't see that on your paper, I apologize. You will have it slightly different than I did, which is okay. All right, so I'm going to label them as x1 and y1. So I have y minus my y1, which is a -5, equals my m of -4, and then parentheses x minus my x1, which is there. Now, I can clean this up a little bit. Minus a negative is the same thing as plus a positive. So I can make it a plus a 5 and a plus an 8. You don't have to. I would actually accept either one of these as a final answer. So now you can see why point-slope form is nice. This one here, number 3, I didn't give you the y-intercept. You would have had to have found the y-intercept. A way you could have done that on the graph was actually taking the time to graph the point, -8, -5. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5. And going up 3 and left 4. So 1, 2, 3, 4 over 4. Or down 3, left 4, down 3, left 4. And I would have to keep going until I found that point here. It's more work. The y-intercept wasn't given to you. If I need it in slope-intercept form, I have to have the y-intercept. So I would have had to actually keep extending it out until I could figure out what this point is. Where did it end up crossing my y-intercept? But because I'm putting it in point slope form, doesn't matter. Any point will work with the slope. Okay, so we've got 3 more to try. Let's check all of our signs. This is a -2, 1. This is a 3, -4. This is a -5, -5, and then a -3, 3. This is a -8, 6, and this is a -2, 9. So you've got 3 problems, 4, 5, and 6. I want you to go ahead and put them into point slope form first, and then change it into slope intercept form. Notice the instructions on this one say slope intercept form. So you can still put it in point slope form first, but then you're just going to have to simplify like what I did up there in the green. Okay, so let's try one. So I have y minus my y1 value. Well, I'll label this as x1, y1, equals my m. Ooh, I don't know my m yet. I'll have to find that. And then x minus my x1 value minus a -2 is the same thing as plus a +2. So I'm still missing the number that goes right here. Okay, so let's find m. So label this as x2, y2. So I'm going to do 4 minus 1 over 3 minus -2. Minus a -2 is the same thing as plus a +2, which means that my slope is 3/5. There's point slope form. If it asked it in point slope form, we'd be done. But it asked for slope intercept form, which is, again, why you can see why I probably like point slope a little bit better. Okay, so let's change it into slope intercept form. All right, so we're going to start by using the distributive property. I'm going to come over here so you can see it a little bit better. So I have y minus 1 is equal to 3/5 x plus, well, 3/5 times 2 is 6/5. Calculator is fine to use on that. And then I'd have to add the 1 over. So I get y is equal to 3/5 x plus, adding 1 is the same thing as adding a 5 over 5, which would make it an 11 over 5 when I add my numerators and keep the denominator the same. So there is what I would have to do to get it into slope intercept form. Okay, let me change colors so that you can see which problem goes with which. So I'll label this x1, y1, x2, y2. I'll go ahead and start by finding the slope first. So 3 minus -5 is the same thing as 3 plus 5. -3 minus -5 is the same thing as -3 plus +5. So I get my slope is 8 over 2 or 4. So now I have y minus my y1, which is the same thing as plus a positive, is equal to my slope of 4, and then parentheses x minus my x1, which was a -5, so it becomes plus a +5. That would be all I would need to do if I'm putting it into point slope form, but I need it in slope intercept form. So going one step further, distributing that, so I have y plus 5 is equal to 4x plus 4 times 5 is 20. Subtract my 5 over with its like terms, and I get y is equal to 4x plus 15. So there's the answer for number 5. All right, we have one more. Try this one on your own. Pause the video, come back, and check in and see how you did. Okay, so I have x1, y1, x2, y2. I do highly recommend actually labeling those, less likely to make a mistake. So then it's y2 minus y1 over x2 minus x1, which is the same thing as plus a positive. So I get my slope to be 3 over 6, which is 1/2. Okay, so now I have y minus my y1 value is equal to my slope of 1/2 times x minus my x1 value, which is a -8. So I'm going to make it a plus a +8. All right, there's my point slope form. You can see again why I like point slope form. I'd be done. but it wants it in slope-intercept form, so I have to keep going. So I will multiply here. So y minus 6 is equal to 1/2 x, and that'll become a plus 4. When I add my 6 over to get y by itself, I have y is equal to 1/2 x plus 10. And there's my answer for number 6. All right, if any of these are unclear, you're having trouble with them, go back, try to rewatch it again, see if listening into it one more time helps. You can always rewind the video to help you if you're stuck, or star it so that you make sure the next time you're in class, you can ask me a question on it and I can go over it with you in person. Okay, last problem. You finished parasailing and are being pulled back to the boat. After 2 seconds, you are 25 feet above the boat. Write and graph an equation that represents your height, y, above the boat after x seconds. And it does tell you you're moving at 10 feet per second. Okay, so we have a coordinate point of 2, 25. And it tells us we're moving at a speed of 10 feet per second. So that means my slope is 10. 10 over 1, which is just 10. Okay, so we can write it as y minus y1 equals our slope 10, and then x minus my x1. Okay, so if it just asks for the equation, this would work. If it asks us to graph it, it's probably going to be just as easy to have it in slope-intercept form, although we can graph it straight from knowing this information here. So if I give myself a little more room there, if I'm graphing this, I can go up by 5s, 5, 10, 15, 20, 25. As long as I label it, I can change it to whatever I want. And I'm just going to go by 1s over here, 1, 2, 3, 4. Okay, as long as you label them, you can make the scale on the x and the y be different. So the point 2, 25 is here, and a slope of 10 means that every second, go up a little bit further, every second it's going up 10. So when I go to 3, that would make it at where? 35, you're right. So I can graph it. I know I'm not going to put anything over here because I can't have negative time. Okay, so I've got my graph. If I want to change this into point slope form, I can. So I'll start by using the distributive property, slope intercept form. It's already in point slope form. So I would have y minus 25 is equal to 10x minus 20. If I add the 25 over, I get y is equal to 10x plus 5. So I can see what my slope is going to be, what my y-intercept is going to be, and so forth. So it doesn't look like I made this quite steep enough because my y-intercept should be down here at 5. So we can add that a little bit more clearly there. Okay, so what height were you parasailing? It means you started at a height of 5 feet. And after 3 seconds, you would be at a height of 35 feet and so forth. So it depends on what time frame they were asking at what your height is going to be. So you can tell them the height now at any time. 0 seconds, 1 second, 2 seconds, 3 seconds, and so forth. All right, take a second to write your summary. Make sure you have y minus y1 equals m parentheses x minus x1. I would circle or somehow remind yourself that those are the 3 things that you're substituting in. If you know those 3 things, you can put it in point slope form. And then I would put something in there reminding yourself how you go from point slope form into slope intercept form. How do you then get y by itself? Use the distributive property and then add or subtract this term over. All right, take a second to write your summary.